Well, good morning, grade 11s, and yeah, I hope you're doing okay with physics. I wanted to remind you a couple of things. Number one, we're going to look at these pulleys today, and it's just we'll just sort of going through the individual types of problems. I told you already it's a unit assignment, so you're gonna, you know, have a couple more things to teach you before you can do the entire thing, but we're getting there. Don't forget, okay, to do these problems here. So I know we've gone out of order. So for example, we've done friction. So we've done lesson 11 already, and I kind of threw that in here, okay, just after Newton's first and second law. And so Newton's third law, we'll come back to that. That's, you could even do these questions. Newton's third law is the action and reaction law. So we'll talk about that, in another lesson. Anyway, we are right in here right now, okay? But make sure you do this friction homework, okay? This here, and you can do that for extra practice, okay? And I am collecting all the homework. I would like to see it in the OneNote folder, okay? So if you don't know how to do that, I will explain it. But yeah, you just sort of go over to your name over here, and let's say you're Abdi, you go into your homework thing, like you can access this yourself, and you just take a photograph of it and just paste it in there. I am going to give you marks for that, like in this bizarre time we're living in now. I need all the marks I can get for you. So these are easy marks. Just do the work, ask questions and so on. I was thinking about having a question and answer period, like just with an online video chat. So I'm going to set that up. I think we said we would do it on Friday. We'll give you a little more time to maybe think about it and ask questions. But anyway, we'll come back to that. All right, so make sure you're doing the homework. Very important. Textbook homework too, not just the worksheets I gave you. All right, so with that in mind, let's talk about pulleys for a second. And in grade 11, we just do what are called simple pulley systems, which means there's usually just one pulley. You can get pulley systems that have more than one pulley and do those in grade 12. But in grade 11, we're just going to stick to one pulley, and so that's why we call it a simple pulley. And let's start with this problem right here. This is a vertical pulley system where one mass is pulling on another one. And what happens is when these things are released, the larger mass, okay, in this case M2, is going to win the race. So here's what happens. This guy, I'll use a better color. This guy is going to accelerate down, okay, like that. Now, if he accelerates down, then, logically, that guy, I'm sorry, I'm having a hard time writing. This guy here is going to accelerate up at the same rate, okay? Now, you notice they're connected by a string. Okay, so ropes can only pull. So that's the thing about tension in a rope. Ropes pull. So what that means is this rope has to be pulling up. So that's tension, right? Pulling that mass up. Now, of course, gravity is pulling it down. And for the larger mass, gravity is greater than the tension. And so what happens is that guy goes down. Okay, now on mass 1 over here, it's got tension also, right? And in fact, because it's the same piece of rope, it's got to be a uniform tension throughout the rope. So those two forces of tension must be the same number. Okay, now this guy has gravity too. But in the case of M1, tension is greater than gravity on the smaller mass, and that guy accelerates up. So anyway, I call these problems, pulley problems, I call them tension and acceleration problems because you're usually asked to determine both. Okay, both the tension and the acceleration in the system. So how do you do that? Well, let's do it. Okay, I'm going to make up some numbers. I'm going to say M1 here is 3 kilograms. And I'm going to say M2 is, let's make it 5 kilograms. Okay, and so how do we figure out the tension and the acceleration in the system? Well, I'm going to zoom out a little. The amazing thing about it is it all comes down to this thing I've been telling you about called Freebody Diagrams. Now, because there's two objects in the system, you're going to need to draw two free body diagrams. Okay, so look, I'm going to start with, it really doesn't matter which one we start with, I'm going to draw a free body diagram of mass 1. Okay, and I have to take up as positive with mass 1 because it's accelerating up. You always take the direction of the acceleration as the positive direction. So for mass 1, that happens to be up. All right, well, the free body diagram looks pretty much like that diagram you see above. There's gravity on mass 1, there's tension on mass 1, and the acceleration is up like this. Okay, so that's it. Now just write an expression for the net force. The net force on mass 1 is going to be the tension force minus the force of gravity. Okay, makes sense because tension is greater than gravity, so we treated up as positive. We subtracted gravity because it's down. And now Newton's second law, you replace F net with ma, and you also replace Fg with mg. Okay, now we know what M1 is. It's 3 kilograms, right? So I'm going to put that in. 3A equals the tension minus, and then 3 times 9.8, 29.4 newtons. Okay, so I'm going to write 29.4. All right, so that's mass 1. Pretty straightforward, right? Now, how many unknowns are in that equation? Well, acceleration is unknown, and the tension is unknown. And I can't solve one equation with 2 unknowns in it. That's not possible mathematically. So I'm done with mass 1 for now. I'm going to call this equation number 1. Now, what we have to do is now do the same thing, but with mass 2. So I'm going to draw a free body diagram of mass 2. Okay, and its free body diagram looks pretty much identical. Well, there's one small difference. There's gravity. There's tension, but this one is accelerating down, and so I have to make down positive on that one. Okay, whatever the direction of acceleration is has to be the positive direction. So I'm allowed to make a different choice for the other object, right? So mass 2 looks like this. Now I'm going to write an expression for the net force. Well, the net force this time is going to be the force of gravity minus the force of tension. This time the tension is my negative force, right? So the tension is going up, gravity is going down, but I treat it down as positive. Now I'm just going to make my substitution. Net force is m2a. This is mass 2 we're talking about, right? And force of gravity is m2g minus the force of tension, like that. Okay? So I'm going to substitute my 5 kilograms in for m2, so it's 5a equals 5 times 9.8, I think is 49. Yeah, 49 newtons, so it's 49 minus Ft. Okay, now look at the unknowns I have in this equation. I have A and I have Ft, the same 2 unknowns. Now, they both move at the same rate of acceleration. So the 2 A values have to be the same number, right? Like if M2 goes down, M1 goes up at the same rate because they're connected by the rope. And the tension is one that rope has the same tension everywhere. So it's the same force of tension pulling on them, right? So these are the same 2 variables. So I have 2 equations. Here's equation number 2. 2 equations, 2 unknowns, okay? And you see, we want to solve for both of those things. What are the 2 things? How much acceleration is in the system? How much tension is in the rope? So I like to use, it's just algebra now. So now the physics is over. We have a system of 2 equations. You just have to solve it algebraically. You can use substitution, but I like to use elimination. So I'm going to take equation 2, and I'm going to write it over here. 5a equals 49 minus Ft. Now what I've done is I've just written equation number 2 next to equation number 1. Now if I add those 2 things together, I notice that my tension goes away. Okay, so I'm using the process of elimination. I get 3a plus 5a is 8a equals, Tension's gone. 49 minus 24. I'm subtracting because 29.4 is negative, right? Okay, so 49 minus 29.4 is 19.6. So I get 19.6 like that. Divide both sides by 8. Okay, so I'm going to divide that number by 8. And I get 2.45 meters per second squared. Okay, so that's the acceleration. Now to find tension, you just have to do a substitution. So I'll use equation number 2, therefore 5 times 2.45 equals 49 minus Ft. I'll just kind of do it quickly for you. You're going to get times 5. So it's going to be 5 times 2.45 minus 49. And I get 36.75 newtons, because that tension force is, after all, a force is measured in newtons. So there you go. That's how much tension's in the rope. That's how much acceleration is in the system. Okay, so that's how you do, in a nutshell, that's how you do pulley problems. Really straightforward. You're always doing the same thing. Okay. Now, there's another question on the assignment that has to do with, I'm just going to move this diagram over a little, that has to do with a box that is on a table. Okay, so let me move that here. So here's a box that's on a table. There's a pulley over the edge of the table. Okay, and then there's another box that's, hanging over the edge. Now, I don't know if you get this or not, but that 6.0, the only way, there's no friction here, by the way. You could put friction in there, but in this problem, there's no friction. But you could put it in, and you guys, we've been learning how to deal with friction, so you could put it in. I meant to write, okay, no friction here. Okay, so look, if there's no friction there, just logic will tell you there's only one way the system can move. Like, you release it, there's only one way it's going to move. It's the 6.3 kilograms may be heavier on top, but there's no way it could pull my other mass up. There's no way, because there's no force there to make that other mass go up. Gravity is going to pull this guy down, right? And there's no way the system could accelerate any other way but this way, where this guy goes down and this guy goes that way. If you think about this as a slippery table, no one's holding that mass. It's going to slide across no matter how big it is, right? It's going to slide across the table. So this is not the same kind of tug of war that you get with that vertical system that we just did. This one's a little bit different. It can only move this way. And it really, even if there was friction, the best friction can do is stop it, like make it so it doesn't move at all. But it could not win and have the thing go backwards. That would be physically impossible, I think. You understand, right? So again, there's tension here like this. And here, there's tension there like that. Okay? Remember, ropes only pull. So that rope is pulling on both masses. Okay? And they pull kind of in opposite directions, right? All right, so how do you do this one? Again, we're going to ask the same two questions. What is the tension and what is the acceleration? Well, let's call this mass up here M1 and this one over here M2. This time the masses are given, right? So let's do a Freebody diagram. Again, just repeat from the previous question. So a Freebody diagram of mass 1 looks like this. You've got gravity, and because it's on the table, you've got a normal force. But then the only other force acting on that mass is a force of tension. Now gravity and the normal force will cancel because AY equals 0. It's not accelerating vertically, but it is accelerating that way. We'll call it AX. So AX is not 0. Okay, it's going to slide across the table. All right, so let's just write an expression for the net force. We can actually ignore the force of gravity. Like if you look at the Y direction, in case you're curious, you get the net force in the y direction. Remember, we're using components here, so the vertical component is just Fn minus Fg, but MAY equals Fn minus Fg, like this. But this one's 0, and you just get Fn equals Fg. And we don't really care about this result, okay? Because we don't care about the normal force in this question anyway. What we do care about is this. What is this number, the tension? And what is this acceleration over here? That's what we care about. So here we don't really care about this. So let's go to the x component. And the x component, there's only one force. Just tension, right? So in the x direction, there's only one force. It's unbalanced. There's nothing in the opposite direction. So therefore, M1A equals Ft. Right, I might as well put in the mass, 6.03. So 6.03A equals Ft. That's it. Now there's still two unknowns. There's still the tension, which is unknown, and there's still the acceleration, which is unknown, right? So we have two unknowns. I cannot solve the system of equations with one equation and two unknowns. So again, I have to now look at the free body diagram of M2. Now this one looks the same as in the previous question, so you're going to get force of gravity like this, you're going to get a force of tension like this. It's accelerating down, so I make down positive. Whatever the acceleration is, that has to be positive. Okay. So now the net force is the force of gravity. I'll just do it quickly because we did this one in the previous question. M2A equals M2G minus Ft. Now this mass is 4.68 kilograms. So let's just work that out. 4.68 times 9.8 for gravity. 45.864. All right. So this is 45.864 minus Ft equals 4.68 A on that side. All right, once again, I have two equations and two unknowns. So once again, I'm going to move this over here like this. Now the rest is math. This is equation 1. This is equation 2. I just have to solve my system of equations. You can do it by substitution if you like, but I always like using elimination in these problems. So I'm going to do 6.03a, although it's easy to do a substitution. It's up to you. It really doesn't matter, as long as you don't make mathematical errors, which lots of people do. So anyway, if I just add these two equations, the tension always goes away. Okay, and I'm left with what is that? 4.68. I'll just use a calculator. I'm getting lazy. 4.68 plus 6.03 equals 10.71. Okay, so 10.71a equals 45.864. So therefore a is equal to 45.864 divided by 10.71. I get 4.28 meters per second squared. 4.28 meters per second squared. And then to find the tension, I just multiply that by 6.03. So times 6.03, and I get 25.82 newtons. So just substituting that number back into equation 1, 6.03a equals Ft. So therefore Ft is equal to, what did I say, 25.82 newtons. Okay, so there are your two answers. That's the acceleration, and this is the tension force. So that's how you do pulley problems, guys. So there's a couple of problems like that on one of the worksheets. Anyway, don't forget to do your homework and post it in OneNote. Okay, it's very important. You do get marks for everything you do. And I'm going to give you, there's still a few more days to work on this. I have to show you how to do 1 or 2 more types of problems, and then you should be able to do everything. And yeah, we should have an extra help session where we do a video chat. I did that with my grade 12s. It worked really well. But anyway, I hope you have a good day, and we'll talk to you soon.